Hello everyone. Hello, how's it going? Welcome back to yet another live stream. My bad, sorry, I was trying to listen if the music is not too loud on my phone and how is the audio. So I hope everything is good. Let me quickly hear it all in here once. Yeah, I think we are good. Okay, cool. Just gonna okay. If anybody is watching right now, just give a confirmation on the chat that the audio is good, the music is not loud, and everything is good. Good. So, what are we doing? Yesterday we were doing Leetcode. So, this is a website that I maintain. And I started maintaining. Yeah, I started this C code, Leetcode in C, solved in C because why not? So, I've been trying to learn a little bit of system programming language and trying to get out of the enterprise. Yeah. So, taking that into consideration, what I'm trying to do here is just hello. I'm good. How are you? How are you, Lokesh? I'm doing good. So yeah, I'm just trying to learn a little bit of C. Of course, I don't think that lead code is real engineering, but learning the data structures and the basic algorithms are pretty important. So I nowhere feel that lead code actually tells you how good of an engineer you are. But yeah, so this is no way where I'm showcasing how to practice lead code. This is no way I'm showcasing how you should lead code and stuff like that. This is just something that I wanted to do, and I thought that okay, I'll do that. So that's pretty much it. Yeah. Okay. Cool. So let's get started. So last time, if we go with I think it was difficulty. Yeah. Okay. So we are here, and we have to do linked list cycle. Like इस साल में BTech किया 2014 I passed out from BTech. It's been a long time. So I'm working for almost 2015 I started my job. So I've been working for 11 years now almost. Beach me I had a break in 2019. 9 months or so. So anyways, 11 years. So let's go to generator and make run, make dev. What is it? Okay, cool. So we have that. One thing I wanted to make sure is I actually do it on the other side. So generator and make dev. Cool. So we have things up and running in my local host. Cool. I think we can get started. So for some reason, okay. So I felt for some, yeah. So the green line kind of disappears. Does it happen on screen? No, it just happens on my preview, which is very weird. Anyways, cool. Problems. Why do I have a make file here? I still have a make file here. I thought I changed it. That's weird, but okay. क्या बात है भैया, फिर तो आपके टाइम पे चैट जीपीटी नहीं था तो बुक से ही पढ़ाई करती, डाउट भी बुक से देखना होता। आई एम नॉट अ कंप्यूटर साइंस इंजीनियर, तो मैं बुक से नहीं पढ़ा था। आई एम सॉरी इफ आई एम स्पीकिंग इन इंग्लिश, आई डोंट थिंक आई एम रूड, आई एम showing off and replying back in English because I feel no matter what people say, English is where you have the most audience. So that's why I prefer to speak in English. My streams are specifically English. But yeah, so I didn't do computer science engineering, so books was not a thing. Like books was a thing back then, but not for me because I didn't have a computer science class. I am a electronics and. No, I understand you are like I'm saying ki you are speaking in Hindi, I'm speaking in English, not showing off. I'm just. So yeah, people. So people used to study from books. I know my friends who were in computer science. Not me, because I didn't study. So my computer science journey started in 2019 when I took a break and I actually really wanted to understand computer science, because before that I was. I'm not gonna name the company, but I was in some projects which really had some IT work. That's all. It was not really software engineering, right? Um, in my opinion, I may be completely wrong. Did I just do Vim? Okay, so what was the file that we are creating? Well, where is it? Are you telling me I have multiple? Yeah, okay, so I have multiple of this open. I need a way for the generator to say that if you have Leetcode open, you just open it there. I mean, sorry, C-code open, you just open it there. Firefox open, you open it there. Anyways. Don't give spoilers, buddy. Why are you giving spoilers? I mean, yeah, that's true. So it's a linked list cycle. This is one of the famous algorithms. So I'm not here to actually teach DSS, so I'm not gonna go through anything if anybody's looking for that. There's gonna be a recreational programming. I'm just doing stuff for the website, and yeah, that's pretty much it. Okay. So I guess spoiler is fine. This is tortoise algorithm. I think it's also called Floyd-Marshall algorithm or something like that. I'm sorry for flashbanging you, but the dark reader sucks, so I don't want to do that. Okay. So if you have to find the place where your cycle starts, if you have to so what is the question? Given okay, so it's just a determination of the linked list has a cycle or not. So there are two parts to it. One, you can figure out if there's a cycle, and second part, if you have a cycle, what is the starting part of the cycle? You can also figure that out. So if you want to do in here, you basically do this tortoise and hare algorithm. I think it's called Floyd-Marshall's algorithm or something like that. So you basically take 2 pointers and you run them twice as fast, like so. So yeah, I don't want to take out my tab for now. I'll just do it with the mouse. So you have a bunch of nodes. This is basically a linked list. You take 2 pointers. Usually the naming is, this is a fast pointer, this is a slow pointer. You would skip this by 2, and you would skip this by 1. Now there's a maths behind it, which I have never explored. I think this is one of the things we should explore on stream maybe one day, because I really want to, like, maybe it's a good idea to explore it on stream, maybe it's not. We'll see. Because I think the understanding the maths behind is important, because like right now, one of the questions that I have in my mind is, since the fast pointer has to be 2x faster, what if instead of making this jump 2 and 1, what if I make this jump 2 and this guy has 4? So will 2 to the power of something always work, or can I also do 3 and 6? Can I do that? All right, can I do that? I guess you have to do a lot of checks I suppose you can do it. The only problem is you have to do a lot of checks so that you don't go out of bounds. It's easy to go out of bounds with this fast pointer. So you have to do a lot of checks. Maybe that's why you always choose 1 and 2. Maybe. So this is one of the questions that I just like I had in mind, and yeah, maybe we should study the algorithm one day. Maths does have the math stuff. Why does it work? Okay, yeah. So this is okay. It's something between related to distance, but yeah, this is not the string for it. So whatever. We can quickly start this. So so I go to problems, and in here I want to say 0, 4, 1. Linked list cycle. Maybe I also create solution C. Right. So this is 141. This is linked list cycle. This is easy. And what are the tags that you have in here? Hash table, linked list, 2 pointers. Okay. Hash table, linked list, 2 pointers. And in here, linked list cycle. Yeah. So you have a struct list node, and in here you have a value, I suppose, and you have struct list node next. What I would like to do is do a type def struct list node. This is my source. I would like to give it another name to this thing. Yeah. Cool. So bool has cycle, bool has cycle, list node, something like that, head. Okay. So of course it's not going to compile because you have to provide this thing. Boolean is not a thing in C. Okay, so how I like to do this is, let's do some prelim checks so that we don't, like, we cut off bullshit right away. If head is null, or head.next is null, so do you return, it has cycle. So if there is a cycle, return true. Okay, so return true. So you do it in that way. Wait, my bad, sorry. False. And I suppose we also have to def. Yeah. So now the error is something different because it's a pointer, so I have to do that. I wonder if, yeah, no, I cannot comment it out because I need for that. Okay, cool. So we both start at the same place, which is list node slow is the head, and what has happening, I mean, I anyways cannot type, so guessing, right? So till what time should you go? Fast can land on the last one. Fast can land on the last one. So let's actually do this. While true, uh, slow is basically slow next, and fast equals fast next next. If slow is fast, just simply turn true, turn false, something. So what is the condition that we should break? Well, I usually go with the code first when working with pointers, or even when you're working with Java and you have this, right? Usually what I would do is go with the pointers and see that what I have to save. So if I save fast next, I should be good, right? Right. So fast is not equal to null, and fast next is not equal to null. So fast not equal to null will save this part, and fast next not equal to null will save this part. And I suppose we can also break in here fast, and that should be it. Hopefully I didn't do anything stupid in the algorithm. Okay. Time to spin a plot. Write the notes.md for problems 014 solution. Follow same pattern as others. Make sure to include this link. Link text is this, and link is in approach section. Something. This is also. This is called visit for. So yeah, I should figure out what I want. Sorry for flashbang. Really sorry. Maybe I should turn it on. Let me turn it on. Okay, sure. Okay. So this is good. Let's do blind. The next one is reverse bits. Okay, this is gonna be a fun one. Reverse the bits of a given 32-bit signed integer. That's important. What happens when it's overflow? What happens when it overflows? Yeah, so I have done this a couple of times. I think the real question here is, if this function is called many times, how would you optimize it? So what I usually do is you try and take out bits from the one side. So you do a right shift and then you generate another number by doing a left shift, right? So that's usually how you do it. But in here, it's a little bit off. It's a little bit off. Did it do a good job? What did it say? Walk two pointers at different speeds, slow one node at a time, fast two at a time. If the list ends, there is no cycle, and fast falls into none. Yeah, if there is a cycle, fast keeps lapping the loop and eventually laps slow from behind. So the two must collide at the same node. The intuition, once both pointers are inside the loop, fast closes the gap to slow by exactly one node. So the distance between them strictly shrinks to zero. They can never step over each other. A meeting is therefore guaranteed when a cycle exists. This is called this thing. Visit for more details. A loop guard check before double, which safety, blah blah blah. Yeah, cool. Makes sense, right? I hope that makes sense. Okay. So what was the name of 190 reverse bits? 190 reverse bits. Solution dots. So one of the things we can do is I want to rename this to dot. Just let me rename. Well, I cannot. What was it? 190. Yeah. Cool. Huh? Okay. So let me actually code this part out, and actually, what I want to quickly do here is 041 solution sorry. This is 190 reverse bits. This is an easy one. I suppose this is divide and conquer bit manipulation. Divide and conquer bit manipulation. Sorry, I'm really sorry. Reverse bits. Is that reverse bits or reverse bit? Yeah, okay. So, usually what we do here is that usually what we can do is we can take up the last bit, right? We can take up the last bit like this, and in here int reverse 0. What we can say is, well, I have to do that for like in a loop, right? So well, actually let me go back, and I think yeah, I think it's, we'll translate into a loop, right? So we're gonna we're gonna take the reverse, and we're gonna take the last bit, and we're gonna left shift it by how many positions? 32 bits. 31 minus 1. Well, this is this minus 1, right? And this is gonna be the other side bit, which I reverse, which I can OR with this thing and assign it back. Okay, but now we have to do that for all of them, right? So int I0 I less than 33, I plus plus. So n and 1, this gives you the last bit. You take this bit and you shift it by 32 minus I minus 1, and let's say reverse or something like that, and reverses this. Yeah. So we're gonna lose n here, but that's fine because it's a value copy, right? It's not a pointer pass, so we should be good in here. So basically the stack is gonna copy over the variable when you pass. Not here. I want to do n is you shift them by 1. When I'm within a block, NeoVim gives this underscore, which is fuck. I don't know why. I have to check my config. I did something stupid. And if I'm not wrong, I think this is it. Let's see. Okay, cool. But yeah, the question is, we kind of iterate this. So maybe today we can spend a little bit time on this, because in here, I'm gonna put the sound a little bit less. Yeah, because in here what happens usually is that, so the question here is that if this function is called many times, how would you optimize it? Even though even though this is O of one operation, so this is where I think like I just wanted to explore if we can actually do better than this, right? I think it's called godbolt in, not in, godbolt dot org. Okay. So if I take this and let's say if I say GCC x8664, yeah, so this is the assembly that creates, right? So this is the assembly that it creates, and definitely there is there's a loop going on here. So my entire question is that can we actually optimize it and not have this like super fast, like have this super fast and not have it go through for loop. Okay, so I am again not an assembly is very far off, right? I'm just learning C right now, but let's try to read this. So RBP I think is register. RBP is a register. RSP is another register. They have different meanings. I don't know what. So you're moving something to EDI. You're moving something to 0. What the fuck you're doing? Maybe, okay, so maybe this one of the 0 is this. Okay, cool. So this is awesome. Yeah, so this is loading 0 in here, and this particular thing loading 0 in here because in time. So you loaded up 3 variables, and what is this? Okay, there's a function call. Like what? You're moving in the input variables. Anybody knows assembly can help out debug? I mean, understand what the fuck this is. But anyways, so then you have a jump, which means jump to this section, which is okay. So you always first check the condition. It checks the condition with 31 because -1. Okay, cool. And there is no compiler options. But if I say O3, does something change? So we can do better, right? So we can definitely do better. So maybe we can go in the reverse direction. So they are doing some sort of XOR and all that. Okay. And JNB is, I don't know, but what is SAR? x86-64. SAR? What is SAR? Shift right arithmetic. Okay. Signed division of a destination operand by a power of 2. can be a register or a memory location. So registered are sorry, sorry, registers are RAX, RAB, RBP, something like that, right? If I'm not wrong. And then you have the memory as RBP minus 8. Maybe I'm wrong, but you just like don't listen to me when I'm talking like this for assembly. But what do you do? So what if I say O1? Okay, so even for the very first bit, you still have a bunch of, you have 14. So if you go to O2, this is when it goes to 13, and O3 is probably 12, or it keeps at 13. It keeps at 13. So this is the most optimized one. Okay. Okay. So this is a function where you say move something, the value 31 somewhere, and then you XOR EDX with EDX, which means you are basically cleaning it out, right? Is it not? Is it not? 6 or 6, you have all the bits same, so it has to be 0. So you're basically cleaning out the register. Why? I don't know. Maybe you put in something. Yeah, so you are putting in something before, so that's why you clean it out. Okay. And L2 is another section. And J and B. What is J and B? Jump if not below is conditional branch used for unsigned numbers. It executes a jump if the carry flag is 0. So you keep the carry flag somewhere, and it execute when the previous comparison instruction like CMP found operand is greater than or equal to the second. Okay. So what you do is so what you first do is, so I think first is destination, then is source, right? Also, yeah, bit. Wow. Sorry, we are going for 2. Yeah, the code remains same, but like it has to be the correct thing, right? Just cannot be stupidly anything. So you're moving EDI into EAX, and you just say right shift. What is SAR instruction? Performs a right bit shift on an integer while preserving its signed bit. Okay. So you would bit shift by 1, and you would perform an AND operation in whatever in EAX, which was basically EDI before doing the shift. 1? What is this 1? You're performing an AND with 1. Then you do a SAL, which I'm guessing is a left shift. Then you do an OR. Holy fuck. What the heck you're trying to do? So you're moving this value. Well, yeah, that makes sense. You don't. What is EX? What is EDI? Let's actually ask ChatGPT. This is a x86 64 assembly. I want you to explain each and every line and why it does this. Let's see if it can actually try to do that. I have kept it on high, so let's see. I'll unpack it as generated x86-64 assembly. First, what register means, then what instruction does, and what tiny example loop so the purpose becomes understood. Holy shit, I actually figured out this function reverses the 32 bits of an integer. So somehow it always took, yeah, so this is what I do. This is what I do. But it somehow actually took an unsigned integer, but we don't have to do that. So register rules, I think it's very small, so I'll just zoom in a little bit. For normal C calling convention on Linux, EDI is the first integer argument. So okay, so whenever reverse bit is called, EDI will have the value. So you're moving EDI to EX, which is if copies over, then EDI is a right shift thing, but preserving the signed bit. Then you do an AND with whatever your value was with 1. Sorry. But you still do a jump, right? So it's still a... EX is a return value. Ah, okay. So that's why you always keep... okay, cool. That makes sense. That you would have your values in... Okay, so you're still calculating stuff in EDX and then you're finally moving it here. If I understand that correctly. This assembly says EDI is the input value, gradually shifted right. Destination bit position starts from... Okay. So I suppose if I say 0... Yeah, it literally, no, it still uses SAL and all of that. I think we should start Leetcode in assembly. Does that happen? Like, anybody wrote Leetcode in assembly? Anybody tried that shit? Does it even have a support, by the way? I'm guessing they are running Linux systems and mostly are x86-64 systems. So do they have a support for assembly? Okay, I cannot type, but I right away don't see assembly. Is there? No, there's no assembly. Okay. That would be a pretty good thing. Leetcode in ASM. Anybody wrote it. Motherfucker. This guy didn't. I saw this video another day where low-level learning used assembly to solve a Leetcode problem. I decided to check out a challenge to solve at least 10 Leetcode problems using assembly. First of all, he says in the video there is no assembly option in Leetcode, so we need to improvise. I will do basically that is inline assembly in C. Okay, that makes sense. I think you just say ASM and put in the code, things like that. First of all, as he says, okay. Also, I'll be using Intel syntax, and instead I'm more comfortable using the AT&T version, so I'll do that. So assembly is hardware specific. I am a bogus, completely noob in this. Defanging an IP address. This guy wrote this entire thing in Nth Tribunachinum. Whoa. Sorry. Wow. And he just didn't take up something. Cool. Anyways, so I suppose this is another thing I have to do at some point, because this is fun. There is no pressure of writing classes. There's no pressure of doing shit like that. But yeah, okay. Write the nodes.md4 problems 090. Keep it precise, brief, whatever. Oh, wait a second. Build the result one bit at a time. For each of the 32 positions, pull n is the lowest bit. Pull n's lowest bit and place it at the mirrored position in the reverse with a shift, then drop that bit off n. After 32 iterations, every bit has been moved to its reflective slot. Blah blah blah. Yes. And this is not drafting. Cool. So, by the way, I didn't actually see how it looks. So, reverse bits. Yeah, looks pretty good. I really started liking this theme, which is Google Dark. So it's a good theme. My terminal is Google Dark, but this thing is Graphbox. I don't. Yeah. Maybe someday I'll shift to this. It looks pretty good. I also have raw, yeah, so it takes you to the solution because I haven't put it yet. That's fine. That's fair. Okay. Oh, 191. Number of ones bit. Okay. Given a positive integer n, write a function that returns the number of set bits in its binary representation, also known as the Hamming weight. Okay. This is also fairly simple. We keep on iterating and doing that, but set. So what we can do is shady case source code GitHub. I'm not gonna copy. So let me actually first do the program. We can actually do that. So number of ones bit. Number of ones bit. So in here, I'm going to create a solution C. Int Hamming weight, int n, int set is 0, and for I equals 0, I less than 32, I plus plus, set plus equals, so we can do that. Wait, sorry. Because it can be 1 or 0, so. And that should be it. That should be it. But the important question is, okay, so what I wanted to quickly show is, so this is a Java spec integer class. How do you call it? Java. Yeah. So this is set count, bit count. Yeah. So the function is called bit count. Yeah, function is called bit count. It returns a number of 1 bits in 2's complementary binary representation of the specified value. This function is sometimes referred to as a population count. Now, if you look at that, they do something really magical. There is no for loop, there is nothing. It's pure bit magic happening right here. And I really want to fucking learn it. I really want to fucking learn it. So, one question here is, where does figure 5 come in from? If anybody wants to get the reference, bit count implementation Java. Yeah. So you can call it bit count, you can call it set count, whatever. But look at that implementation. Who the fuck came up with this implementation? Can I do a git blame here? Eight years back. Simplify Java implementation. Wait, what? Oh, this was still like initial load. It's not there. Anyways, we can maybe explore the Java source code one day. These are some good ideas to stream. I should have a. What do you folks think? Okay. Yeah, we gotta do some bookkeeping stuff. So this is what? 191. This is what was it? Number of one bit. One bit. This is easy. This is what? Divide and conquer bit manipulation. Divide and conquer bit manipulation. And here, of course, is this thing. Cool. So this is done. How many users are left? Couple of users are there. So reverse a linked list. Sorry, I'm really sorry. I hope that was. For a moment I saw it go to red. I'm sorry. Sorry. I hope that was not too loud. Reverse linked list. Solutions. So 206 reverse linked list. This is easy. This is what. So let's quickly grab this guy. Okay, be sure we can do this. Topics are linked list and version. Linked list of course. So let's actually start saying type def struct list node, and here I'm gonna say struct list node int val, and you can have a list node next. This is a very straightforward solution. This is a very straightforward solution, and how are we going to do that? So we're going to do two ways. Once we're going to do a recursive solution, once we're going to do a normal solution. And for this particular one, what I want to do is first go through a normal solution and let's just do the reverse. If anybody here still wonders how we can not reverse xcali how we can do it, it's a very, very simple strategy of how you're going to do it. So you have a node. Let's just say 3 nodes. Okay. You have 3 nodes. Awesome. What you can do in here is you can say previous is null. Sometimes for some cases I like to have a dummy. Some people do it here also, but maybe you can do it, maybe you cannot. So I am more accustomed to writing it like this. I say this is my current node and this is my previous node. Okay. And I'm going to iterate till my current node is equal to null, not equal to null. So once it becomes null, which means once it reaches the end, I will then exit out. And of course, there's a thing that it doesn't have a cycle. If it has a cycle, I think you have to do some extra things. You can still make it work. But yeah, that's that. Now, if you look at it, this is current, all right? So the idea is very simple. Can I write it in Excel? Yeah. So while current is not equal to, so let's write some Python, is not none, right? So while current is not none, we keep going. What do we have to do? If you look at it, previous dot next is equal to current. If we go in a forward direction, we just got to reverse it. Current dot next is equal to previous, and that's all. That's all we have to do. Current dot next is equal to previous, and then we shift the pointers by one. So previous now becomes current. So now this becomes previous, and this, so this actually got like this. So this is pointing towards a null, but one was pointing to 2, but we changed this thing in here, current next. So this pointer is gone now. So how do you even jump to the next one? Well, a very simple answer is save it. It's basically swapping 2 numbers, right? You had 2 numbers, you had a third variable. That's basically it. Current equals next. That's all. That's all we're gonna do. So let's actually code that up. So in here, list node previous is null. This is current, and sorry, while current is not equal to null, list node current next is previous. Previous equals current, and current equals next. So we have to store the third variable because it's lost. So list node next equals current next. That's all. Of course, you cannot do that. These are pointers, so you have to do them this way. Makes sense. And you simply return previous year, because when current is a null, this is when you stop. Previous would be this, and technically speaking, when you reverse it, this would be the head of the list, right? I think I have to hash into std library. Will that work? Ah, it didn't quite work because it's a pointer. Yeah, I need that. Cool. Uh, well, this thing, and let me quickly run it. Wrong answer. Why is it wrong? Aha. Yeah, cool. Makes sense. But we are also going to do a recursive solution for this. List node, reverse list, recursive. So, if you think of a recursive solution, it basically means that for every unit of work within the single function, right? What you have to do is you have to reverse two nodes, swap away two nodes. That's all, and move the pointers. Is that not it? Right? So one of the things what we have to do in here is we actually have to pass two of those. So this is the current, and this is the previous one, right? Yeah. If current is null, I'm gonna just return the previous one. That's all. So in here, you're gonna pass head and what happened? Too many. Oh, yeah. Makes sense. Kind of makes sense. Why are you complaining? Call to undeclared. Oh yeah, I forgot. Sorry for that. Yeah, cool. Now, what you have to do in here is that correct? Or do we return current? I suppose we return current. Now, what I want to do in here is current. So list node next should be current of next. Now we swap the pointers. Current of next is previous, and then we have to reverse this thing and call the current becomes next, and this becomes this becomes current. and you return that. Because this is this, and this is this. This is also a pointer. Cool. Now we are going somewhere. What if, of course, I have to put that at the top, and in here I just call this function. If I am not wrong, hopefully, this is what should be done. And that's wrong. Awesome. What did I do wrong? Let's quickly see. Uh-huh. So, while current is not null, do you return previous here? Yeah. Why? Because so if current was also null, you simply return previous, which is always null, so it just returns null. Makes sense. Yeah. So if it's only ahead, it would go for the next iteration. Okay, cool. Yeah. This is a recursive thing. Huh? What? 190. Where is foo? There's no foo. Okay. Yeah. Write the notes.md for problems 0. What was the problem number? 0206. Sorry. Exit out. And of course that reverse the links in place with 3 pointers, walk current down the list and at each stash. Cool. But one thing we have to notice, is becomes O of n if we use recursion. Because stack space is nothing. Cool. Did we remove solution drafts? Yeah, we did remove. Cool. Okay. Next what contains duplicate. Oh man, I really don't want to implement a hash map right now. Given an integer array, nums return true if any value appears at least twice in the array. Return false if every element is distinct. Hmm. Return true if any value appears at least twice in the array. So one of the things you can do is a hash map, and you can always do a count. But I'm getting that there is some kind of trickery in here. There's some kind of trickery in here. You know what we can do? We can use XOR, I think. So, um, int XOR is 0 because 0 XOR 0 is that number itself. Uh, I less than size plus plus XOR equals XOR nums of I if XOR is 0. Return true, return false. Because if you have duplicates, in the very first time you create a duplicate, it's gonna be 0. Because every other combination is gonna give you any other number, but not 0. That didn't fucking work. Why? Hmm. 0. Okay. What is the number itself is 0? So what is the length? The length is given to be this thing. So what we can do is nums of 0, and we always start with 1. That still didn't work. That didn't work. Okay. Looking at the num length, I don't think so that 10 to the power 5, right? So if I'm not wrong, there was a thing, time complexity based on constants. So yeah, so if anybody is interested, this is the chat, this is the link. Oh man, power went off a bit. Okay, it's back. Okay, so if it's yeah, less than 10.6, it has to be somewhere around n log n. So yeah, so it has to be n log n. I was trying to do often, that didn't kind of work out. Contains duplicate. Given an integer array, nums return true if any value appears at least twice in the array. Return false if every element is distinct. Right away, we can think in terms of hash map. The only problem here is that with hash map, you will end up having a lot of memory. So we have to come up with a different thought. And more importantly here, if you want a true good hash map, your idle bucket size is 10 to the power 5 into 2. Oh, sorry, wait. 10 to the power 9 into 2, because it's on either side. Plus 1 I put, because 0 is also there. So those may number of buckets. So why not just create a array and look up, right? That's my take. But then of course it's not amortized. Sorry, I mean this is not how hash maps work, which also means that for an array you are always of O of n. Yeah, just ignore it. Okay. Anyways, got distracted. Mm, hmm. That's an interesting thing to think about. Yeah, my understanding is wrong because two numbers XOR together, which are same, is gonna end up being zero. But zero XOR something else because those something else numbers were picked up by. So I suppose we have to do a set to do a lookup. And I really don't want to write so much code right now. Specifically, it's 10:17 and it's dinner time. So we're gonna continue for. I don't know if tomorrow I'll have time, but let's see. Sometime in this week, I'll again come online and start doing it. But yeah, till now, that's it. We did four easy problems in 1 hour, 15 minutes each, plus me talking, doing chat. So I don't think so. It's that bad. Uh, and if it's bad, who fucking cares? It'll be fun. 141. Leetcode 141. 90. Blind 75. Easy. Easy. Yeah, cool. So I'm gonna go offline. Sorry, 10:18 for our time. I'm gonna have dinner, and tomorrow morning is gonna be again another office day. Oh, I miss Saturday, Sundays. This last week was very hectic. I still got some time on Saturday to stream. No, Sunday to stream. I think I'm like it was so damn hectic that I lost track of days and stuff like that. But yeah, cool. Okay, so yeah, again, it's a recreational website that I'm creating. Why? There's no really reason of why, uh, but if you like it, this is the code base. We're talking. So I do not want this for GitHub. Yeah. So I have a generator, by the way. So this generator is completely made by hand, and it's not Jekyll or something, which is actually serving, like creating the files, which is being served. So that's pretty cool. And did I? No, okay, I pushed it. Yeah. So that's that. And then I have problems, which I'm trying to keep in a way where it's all sorted numerically. Uh, yeah, so just make files for nothing. I don't know what's there in README and stuff like that, but yeah, everything is under MIT license. Oh, I'm very sleepy. So yeah, this is the website. If you like it, do visit it sometime. It's not a blog post. It's gonna be a series of all Leetcode solutions. I can generate this using Claude. This entire website design is by Claude, but then it won't be fun. So I'll use Claude to actually generate the Notes MD. Notes MD is something which powers this thing, which is the approach and then complexity. All custom process written in Go just to spit out this HTML files. But yeah. I wrote a priority queue in C. Maybe it's not really efficient because of the fact that I allocate stuff. I don't realloc also because this is a sized priority queue, a bounded priority queue. So I pre-allocate the size. But maybe a better way to do things is arena, where you have a pool of objects and you take the arena, and at the very end you just free them at one go, right? So maybe that's that. There's definitely memory leak in here because oh I actually do free it. My bad. My bad. I never really thought about it. I actually do free it. Okay. Anyways, whatever. So yeah, thank you so much for whoever tuned in today. I'm working on my first video, which hopefully will come out soon. So I'm right now working on the storyboard. Then I'll be working on creating the video. So hopefully by this month, my first actual made video and not live stream will be coming. Uh, yeah. So watch out for that. If you have still not subscribed, consider subscribing to the channel. If you genuinely like the content and feel that there is some potential to actually go somewhere, yeah. So 490, look at that, 490 subscribers. So just 10 away from. Yeah, so just 10 away from 500. So yeah, if anybody is watching, you haven't subbed, it would be great if you really sub. A lot of motivation, a lot of fun. Thank you so much for watching, and good night. I'll see you again in the next stream. Thank you. Bye bye.